Hello and welcome to Android Developers Backstage. I'm Romain from the Android Toolkit team.
I'm Tor Norby from the Android Studio team.
And I'm Fabien Sanglard, also from Android Studio team.
Right, you're outnumbered, Romain.
Yes, although I've worked with Fabien not on the studio team before. And we wanted to have Fabien here today because he's been working on very interesting things. Some of them are very technical and low level. And some of you may actually know Fabien from some of his writings. He has an excellent blog where he talks about how could I describe that, like old school games?
Mostly that, yeah.
Yeah, where you've described how some of those old games like Another World or Doom work. And you've even written books, right?
Yeah, I read one about Wolfenstein 3D, one about Doom, and one about the arcade machine that runs Street Fighter 2 and Final Fight and all those titles from Capcom.
Yeah, and in my humble opinion, anybody who's interested in computers should read those books to understand how those games work. Like, it's fascinating, and some of the techniques they used were like just wonderful.
Thank you. Yeah, even though they are very old technology, I think there is something to learn. Even just if you get some inspiration about how people manage to overcome challenges, it's always the same story. Even nowadays we have like big gigabyte workstation, but we have what we have, and we need to make things better. And it's always the same story.
Yeah, actually, funny enough, a couple months ago, so not quite Doom and Wolfenstein, but Quake 3, I think, they had this crazy optimization for the fast inverse square root. And I used a similar optimization for a fast cube root in Compose, and it made a lot of things faster. So yeah. It's still relevant today.
It's nice if you have tons of RAM and 20 processors, but we're ultimately, at least for Android, you're going to draw battery for all that. So even if it is fast enough, it's always better if it's faster. So I think for Compose, you spent a lot of time optimizing. That is a big theme for this year's version of Compose as well, right?
Absolutely, yeah.
Actually just shaving bits. And I think that the games really were pushing the envelope on that.
Mm-hmm. Well, but also I think interestingly, like reading about those techniques is a good way to gain a better understanding of how computers work, which I think is, a useful skill to have in our line of work.
It's especially interesting to study the system because they are small enough that you can understand them, or sometimes they are big enough in terms of, like, if you look at the motherboard, you can actually follow the bus lines. You cannot do that with a SoC. Like, if you open a Pixel or any phone right now, it's just so tiny, you cannot look at it. Same thing with the software layer. Doom, you can actually keep all of Doom engine in your head and know how it works. I could not tell the same thing about the Studio or any other.
But yeah, you had an article recently about the Super Nintendo, and you have photos of the electronic boards that go into the cartridges, and it's exactly what you described, right? Where you say like, oh look, you look at this pin, it's the clock, and if you follow the wire, you can see where it's going, and yeah, you can just look at it and understand what it does. It's really cool.
Yeah, it's so cool.
All right, but
how does that map to Android Studio? Do we have any low-level things in Android Studio?
So have you used any of those things that you've learned, like, through this work? Like, have you been using them on Android Studio?
So what I've learned going through those old things is to go to the bottom of things and really learn to master the whole stack. I never want to limit myself to one layer and be like, okay, we just throw it overboard and like, this is not my problem anymore. And this is exactly the way I've attacked every problem I was trying to solve. So for the past year, I've been working a lot on the debugger to make it better, faster, and all those things. And paradoxically, I haven't been working on the debugger. I've been working on ADB because what powers the debugger is the communication line between the workstation and the phone.
It's funny you mentioned that because I'm sure it happened to all of us where you set out to solve a problem and then you're like, oh, I need to do this before. And then at the end, you're working something like, wait, what was I trying to do in the first place?
Sometimes it feels this way. But yes, so mostly, lately I've been mostly involved in ADB because the first thing I did when I looked at the debugger is that I started to trace it. And I was looking at the wire level. At the lowest possible level, I was looking at the packet transitioning on the network. And when I did the trace, I saw a little bit of communication, huge gap. A little bit of communication, huge gap.
So basically, we're spending a lot of time not doing anything.
Nothing was happening. I was like, what's going on? Are we doing a lot of calculation on the workstation? Like, what's going on? So that to be at the lowest level really opened my mind about where to go dig and where to find stuff. And I'm going to take those two examples about the debugger and like how we made life easier for developers. So the first big gap, it was 1.3 seconds. Nothing was happening. I was like, okay, what's going on? So I started to chat with the team, the people writing the layer, talking to ADB. I looked at the device itself, the OS, and it turned out it was just a coding mistake on our part. So there was an active loop that was sleeping, and we were starting with a sleep instead of sleeping after checking. So that was on us. This one was solved in like one morning. I talked with Renaud.
So it's nice when you find these kind of bugs like, oops, someone left asleep.
It's one of those great things when you start on a project, you have those low-hanging fruit, and you're like, oh yes, you just put it and you put it in your basket and you keep on going.
And this was on the actual connection speed, right? You try to attach the debugger, and that's when it was like doing an extra second.
Yeah, a second and a half wasted, and when you have millions of developers, that had up pretty quickly. And I was okay, cool. Let's do the second one. By the end of the week, I can already have a nice report for everybody. And the second gap took 4 months to solve. So the second gap, it was actually a problem with the phone. And the way it was done, okay, you need to step back a tiny bit. The way a Zygote specialized, originally the way it works is that nothing stops. When you debug a VM, you can start it in suspended mode. Mm-hmm. So it suspend, debugger attach, sets the breakpoint, and then resume. Everybody is happy. The way it worked on Android is that Zygote start, specialize, and goes to uncreate, and never stop. So what the people did back in the days, they were like, okay, we need to find a way to let the debugger attach and set the breakpoints, because if you put a breakpoint on create, you may miss it. So they're like, I know. What we're going to do is that we're going to just have a busy loop, and we're going to wait until the debugger shuts up. As soon as it stops talking to us, that means probably the breakpoints have been set, so we can resume. So after I digged, that's what I came around. And I was like, how long has this code been there? And it's like initial import, and it was 2009.
Yeah, so it's interesting because, so the 2009 is what I call the event horizon, because that's when we switched from Perforce to Git. So there's a lot of code history that's not lost because we still have access to the old Perforce, but it's hard to see like the true root of that code. But yeah,
I just always infer if it was before that, it was probably someone's quick afternoon hack.
That's what I was going to say. It's, when we started Android, we had nothing, right? We had to build up everything. And so a lot of it was, let's just have something that works and we'll figure out later. And I think I forget if that anecdote was in Chet's book, Androids, the one day when one of the engineers on the team was mad at another engineer because he had been debugging a prime all morning long because he was using a weak hash map. And then finally he looked at the source code of weak hash map, and weak hash map just said extends hash map. And that was it. And that's because,
hey, we need a weak hash map.
We need to compile something. We need a weak hash map. So like, so yeah, I'm not surprised that you run into something.
But it's a good point you're touching, is that when I come across stuff like this, I'm never judgmental. I'm never like, what about thinking and stuff like that. I fully understand that there was a time where Android...
There was a reason.
There was a reason. And everybody... Especially when I know the people who worked there originally, they were all good and they are all dedicated. So, I mean, it's just they had to ship and they put it there, and it was working reasonably well for many years. Otherwise, Bugzilla would have been on fire. So it was working well. It's just that it could work better. So yeah, in the rest of this chat, even if I say something, I'm not never judging.
Okay, if it's code I wrote, then you can judge.
Okay, all right. So I found this active loop, and there was even a cute comment about how with USB 2 it can take the debugger up to 500 milliseconds to send all the stuff. So just to be sure, let's wait 1.3 seconds. And that was a really I don't know. It was a really warm feeling to read about this guy who was like working with this kind of technology. So yeah, it took me many months to fix it, because as soon as you touch code like this, you don't want to break anybody. So it has to be backward compatible. And it touched to framework, libcore, ADB. So it's a repo across multiple, it's a topic across multiple repos. So 4 people are going to review your code. You need to prove them 4 times why you think this is good.
But I think it's one of the things that's super interesting about working where we work is that sometimes you end up having to do something that cuts across the entire stack. I remember when I worked on color management, I had the same exact issue. It's like, okay,
I remember that.
Now the app is rendering with a different color space, but when we take a screenshot, the information is lost. Okay, it's like you have to plumb through Window Manager and Surface Flinger, and now the screenshot tool, and then ADB, and then you're in Android Studio and you're fixing Swing. And
do you remember how many repo you ended up touching?
I don't know.
I remember
too many.
You a while, yeah.
Yeah. But so same idea. Like sometimes the fix, and that's I think what you were saying earlier, right? Like if you know or are willing to get to the bottom of things, you're not afraid to like go through all the layers that you need to go through to fix the problem, because otherwise you get stuck.
Well, it's also if you were a game developer, you sometimes you were just a game developer, you couldn't go and change the OS on the game console. Like it was kind of like you just had to do crazy hacks. Here you have the power to go and like, okay, let's change OS, let's change ADB. It's not one of those things you just have to stay away from and work around. You can do a proper fix, which is nice.
Absolutely. I agree.
So yeah, you poke through everything.
So I poked through everything, and what I ended up doing is adding a suspend function. Because, so they could not suspend back in the days because they were using Dalvik. But now we have Art. And with a TI implementation, which lets you do anything you want. So I just added a bunch of things everywhere. And now when the VM starts, it suspends. And then it just sends a packet to the debugger. It's like, hey, when you're ready, please just call resume. And when you have a fast USB connection, you don't even see the message, waiting for debugger anymore. It's just like, goes back. And that feels great. And there was a side effect to that, is that I was fixing it to make it faster. And later on, I learned that I actually fix it for people who had a very high ping. So let's say you have a device in a Firebase data center very, very far away. You put your breakpoint on create.
Maybe we could just add a little context there, is that one of the features we are launching in Studio now is the ability to talk to remote devices.
Exactly.
And that's when we really discovered, hey, we have to do something about debugging because it's incredibly slow. We can't have people have 2 minutes of attached time. And that was one of the factors in sort of like, basically saying, hey, Fabien, can you go and sort of look at making debugging?
Can you go fix everything?
Yeah. So there you have extreme latency.
Extreme latency, which makes the debugger really slow, but also makes you miss the...
Yeah, because you said there was a timeout of like 1.5 seconds.
Exactly. So if it's far away, it waits. It's like, oh, you're not talking anymore. Let me resume. And like, hey, wait, I had a breakpoint, but it's gone. So the thing that it starts suspended now is like, it stays suspended as long as the debugger does not resume. So that means that it's amazing if you have low latency, you don't wait. And it works if you have very high latency, you never miss a breakpoint. So I mean,
best of both worlds.
The second one, I didn't. I was like, I meant to do that for sure. But yes, that was a recall.
That's awesome. And so I assume like to do this kind of work, that means you had to touch like it was not just Java or Kotlin code, right? Like you had to go touch native code.
Oh, mostly native code.
Okay, mostly native code.
And amusingly, I had to touch the debugger agent, which is entirely written in C.
Yeah, we still have a lot of C.
And I was like, oh my God, like it's still working in C, and it works really well.
Yeah. I mean, to your point, right? Like it's the problem with some of those hacks or older code. Like, being old doesn't make the code bad, but if it works well enough, we don't have any reason to go look at it until someday we finally fix it.
Yeah. We had many challenges with accommodating a debugger being far away. So, for example, I'm always trying to judge how many details to give, but I'm going to straight away and just.
This is a detail episode. Plus, it's all right. It's very technical.
So, for example, if the debugger is when you hit a breakpoint, the debugger, the first thing it does is retrieve the stack trace. For every single line, it takes 5 calls to the VM to build a line, because you need the class, you need the line.
So you mean there's 5 calls between your debugger and the VM that's hosted on the device?
Yes,
for every line. It goes over the wire 5 times.
Exactly.
Okay.
Exactly. Thank you for the summary. Yeah, that's a lot of packet. And if every message takes 200 milliseconds to go, you can calculate in your head how long it took to retrieve every stack frame. So when we were testing at the beginning, we were like, oh my God, it's like a slideshow. Every line is like poop, 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 poop. So the cool thing, again, it goes back to knowing the whole stack, not being just at the GDI level. GDI is what issues the command. Is that I've learned the wire protocol. I'm like, okay, so it's really slow, but if we hit a breakpoint, we know what stack trace is going to be requested. We know the packet in advance. So what I can do is that I can build something that I ended up calling S-cache, speculative cache, which send in advance all the packets that I know the debugger is going to send. And by the time the debugger send them, I already have the answer. And that's what made the stack trace retrieval instantaneous, because we speculate on what packet are going to be sent. And again, that made the debugger better for people who have a high latency.
So it's interesting because I forget who said that, but it's a quote I really like about optimization, where it's basically where there's one, there's many. And very often, in the kind of graphic optimizations I've done or what you're describing, it always boils down to, well, yeah, if you're going to do this 5 times, how about you do it once and you ask for 5 items at the same time, right? I know it sounds obvious, but very often that's the issue.
And very often you can't because the protocol is fixed. And so here, I guess you worked around that by saying, well, we can make it fast because we know what's going to come next. So even though it's separate messages, if we put something in the middle, we can quickly answer.
But you made an interesting point early on when you say we can influence the platform. And when I was trying to solve this problem, I was like, how do I solve it? Because I'm like, you can extend the wire protocol. I'm like, do I create a new packet and put it in art and then make the debugger do it? I'm like,
yeah, but now you have a new version of the protocol, and
you have a new version of the protocol, and then it's going to take a lot of time to spread. But in the long run, it may be a better investment than having this thing in the middle. So I'm like, I'm going to put this thing in the middle for now and see how that goes. And in 12 years, people can come and look like, what is this thing?
Who built that?
But here again, it's, we don't control the stack because we are also reusing the IntelliJ debugger here, which is also sharing a lot of implementation with Java desktop, for example, which we have no influence over, right? So I guess that's another constraint is that, there's some parts of the system you can really make faster. So I guess that's a good contributing factor here. We're like, I don't want to break all of JDI.
Yeah.
I want to make it fast in this scenario.
But your example is very interesting because to me, it shows that every time you're dealing with network, it's very easy to make the mistake of assuming that the network you're testing with, which happens to be very local most of the time, is going to be fast. And I've seen that in a number of applications. It's gotten better over the years, but I often go on road trips through the desert in the US where there's very little coverage. And the number of apps would just stop working. Like even opening a context menu sometimes apparently makes network calls and they never thought about it. And I have to wait 2 minutes for a context menu to open.
YouTube Music too seems to often take a second or two to sort of refresh the screen, especially when you're in bad network. And I'm thinking we probably would do our developers a favor if we were to slow down the Google Wi-Fi.
We used to
just kind of train all of our engineers.
So I don't know if we still do, but we used to have for the Android team, we used to have a special slow network to emulate bad network connections on that purpose. But my point is it sounds like what you're discovering is that if you're going to do sockets and packets, find a way to test, what happens with high latency and
it's to the point where I feel like a lot of developers don't know how TCP works. They don't know that when you read, sometimes you're going to get back 1 byte. It's not necessarily the whole packet you sent. And I see that online a lot. Yeah.
But so your speculative cache fixed it.
Yes.
And so what happens if your cache is wrong? Like, does that happen or like?
So I have stats in it and it's actually never wrong.
Okay.
Yeah.
Be careful, like you say that. But
yeah, I mean, not that
I'm
I've
never
said it, I'm going to go connect and like, hey, his cache is broken and everything. But it's something where it's very easy to disable.
Okay.
We've been very careful and prudent in the way we've put it out there.
What are the versions of Android Studio and potentially ADB and potentially Android that you need to sort of get this sweet, faster debugging experience?
So for the debugger, it's completely done on top of Studio. So any version of ADB will work.
Okay. And which, is this in Jellyfish?
It's in Jellyfish. And the optimization for the debugger, I did them 2 years ago. So on the device. So all the device right now probably have it.
Yeah, so you say like it works with any ADB because I assume once you've created the connection, ADB is just a pipe, right? It's not,
Exactly.
It's not doing anything.
Exactly.
Okay.
But so it sounds like probably you want like Android 13 or 14 for this. So if you're debugging an older API level, you're still going to have some of
You're
those
still going to
latencies.
get this waiting for debugger. I mean, the easy way to tell if you have all the optimization is that the waiting for debugger right now on a USB connection, you barely see it. If it stays and you can read the text, you have the wrong version.
And you said the speculative caching, the fast stack recall, all that's going to work basically any version of Android as long as you're using Jellyfish, which just launched, well, today for us at the recording time and a few weeks ago when you see this.
Yes.
Okay.
So what else did you do to make the debugger faster?
So something I did to make the debugger faster is that I got bit numerous times using a bad cable. And
you mean USB cable, right?
A bad USB cable. So, and what I call a bad USB cable is that when you have a USB 3 device and you plug a USB 2, you plug it with a USB 2 cable, it silently reverts to using USB 2 speed. And
so USB 3 is one better than USB 2, right? Which was one better than USB 1. I'm just
which USB 1 and which USB 2 you're talking about, because there was full speed, high speed.
It's so complicated.
Yeah, it's so
you know what? When I jump into it, I was like, this is so complicated. I never understand. And actually, once you know what it is, it's very simple.
Well, the problem is the marketing terms are really confusing.
They are very loose. You can actually market a USB as USB 4, something that's USB 3 nowadays, by playing on the words. But really, it's just a matrix with two axes. There are generation and there are multipliers. And it's whatever you have for somewhere. But then the name is just, it looks like mangled. So it looks very complicated, I agree.
So what is a bad USB cable? Let's say I buy a USB cable that I think is USB 3, but I'm not getting...
Okay, so as usual, I'm going to go a bit into details.
Go ahead.
All right. At the beginning, USB 2 cable, there were 4 wires in it. One for power, one for ground, and one D plus and one D minus. And the plus and the minus, it doesn't mean one goes for upstream and not from downstream. Those are intertwined twisted pairs. So it's called a lane in USB parlance. And that's a half duplex bus, meaning that it's time divided. And at the beginning, you had every millisecond, you could send a packet. And it could be either go up or down. And it could be either of the 4 types. And the bandwidth was what it was. But that's in essence is a USB 2 cable.
Well, look, I remember when USB 2 came out, it was so much faster than USB 1. So, little story, when we started working on Android, like our first development phone was USB 1. And whenever UX would give me a new version of an asset and had to re-upload the system image, which was only 60 megabytes, that would take like a minute or 2.
More than that, probably.
Yes. And every time we tweaked a pixel, and it's like, so when we got USB 2, I was very happy.
Yeah, well, no, when I have USB 2, I'm very unhappy.
So half duplex means that it's one direction at a time.
Exactly. Okay. Yeah. So the major improvement with USB 3 is that the first version, you had 6 cables. So that means, 8 cables. You still have the 4...
8 wires.
8 wires.
In one cable.
Yeah, sorry. 8 wires. So you still have the 4 original one for 2 for power, 2 to carry the USB 2 data, and then you have 2 extra lanes. So 2 pair of twisted wires, and one is fully dedicated to upstream, and one is fully dedicated to downstream. So that means it's full duplex, which means that it's no longer time divided. And for the debugger, it's very important because that's not the bandwidth I'm after to make the debugger faster. It's about latency.
Yeah, because the amount of data you send over the wire,
it's minimal.
It's nothing.
But it's just you want it right now.
Right.
Especially when you're retrieving a stack trace. Anyway.
Yes.
So that's the thing that, and I did a lot of testing, and you're operating in degraded. It's really degraded. It's not the debugger as I want to people to see it if they use a USB 2 cable. And the problem is that it's very easy to make the mistake. And it used to be easy. So to not make the mistake. So when they came up with USB 3, they came up with color code.
I remember the blue cable. Right?
Exactly. So I gave a talk to ADS and I was like, if you want to pick the right cable, look for blue. If there is a blue inside the connector, you're good. If there is blue inside the workstation, put it there. and you're golden.
And if you see red, it's power only and it's not going to work at all.
Well, they had like a whole sort of coding, and yeah, I never went into that. But yes, no, white was like always on. Red may have been power on.
So yeah, red was
Yes.
power only because actually sometimes it's what you want to use if you just want to charge your devices and you're going to use a USB port, let's say at the airport.
Mhm.
Use a red cable because you know there's no data that can go, like there's no data wires. So
if you're a hacker, you want to put a red sticker on your blue thing so that you
Exactly.
can attach people's device.
Mhm.
Got it.
So yeah, if you pick blue, you used to be golden. And then they came with USB-C connector, which coincided with the release of USB 3. So a lot of people and developers made the association that, oh, if it's a USB-C cable, it's also USB 3, and it's not true.
yeah, because what's difficult with USB-C that it means multiple things, right? It's the connector, it's the spec, but then there's also Thunderbolt that can go over a USB-C cable because it has a USB-C connector. It's
I think Thunderbolt use USB-C connector,
yeah.
and they share the same specs.
Okay. But yeah, I mean, the names are super confusing. But so you're saying
So
you
the
can
key
have...
thing is USB-C might still be USB 2.
Exactly.
Right. So
That's
because
the-
USB-C is just
yeah, if
it's
you-
the connector. It's the physical appearance of the cable. It's not about like...
Yeah, exactly. And the thing is that just touching the cable, I have many, you cannot tell how many wires are inside. So visual inspection is not enough to tell if it's going to be working well or not.
And they
And-
did not carry forward the color thing then.
Yeah, and there is the color doesn't mean anything. And it's even worse because if you buy a phone right now, most people, they don't develop on them. All they want is to charge. So the wire, the cable you find in any phone from any manufacturer and
It's the cheapest.
is the cheapest possible.
So
and they
4
are-
wires instead of 8.
Exactly.
And that's not just Android. That's like you're saying all mobile
Yes.
operating systems tend
All
to
of
put
them.
cheap
All of-
cables because it's meant for charging, not development.
Exactly. So, and people don't know. And they're like, oh, that's a pretty white cable. Let's just use that. And it's very neat, but the speed is no good.
If only there was a way to find out what kind of cable one
If
had.
only, that's what I was telling myself
But
6 months ago.
before we go into those details, this reminds me a lot of the same issue with like SD cards or memory card readers, right? Where there can be a vast difference in speed depending on which card you buy.
Mhm.
If it was meant to be read-only, right? It's a mess.
So what do we do about it? Does
What
anyone
do
have
we
any
do?
ideas?
We quit tech
We quit tech.
because it's so confusing.
I know. We know what we can do. As soon as the device connects, we send a huge file and we measure how long it takes. And then depending on this, no, you don't do that. So what we did when we decided to tackle this problem is that we looked at ADB. The key was going to be ADB because that's the one that is connected to the USB controller.
Yeah, and it handles all the USB stuff.
Exactly. So by looking at the spec, I've learned that the USB device tells you what its it has a bunch of descriptors, and one of them tells you what's the maximum speed it can achieve. Great. And if you look at on the OS, they tell you what speed was negotiated. So if you get those two values, you compare them, and then you can warn users.
Yeah, because I was going to ask, like, are there devices that, lie about?
No.
Okay.
So that was also my fear, but with the USB controller, OS controllers, they are usually pretty honest because a lot of bad things can happen. Like,
Okay.
You're not talking to, it's not the cable that's providing this, right? You're talking to, like, it's the USB port on your laptop that is telling you what it believes. And then it's...
Yes. Oh, I mean, the USB device must advertise descriptors. So you get that descriptor directly from the device. And then the OS on its side tells you what speed it negotiated between the two hubs.
Right.
I
But
just device, like we're talking about the USB chip on your computer, not the cable. The cable isn't the device, right? Or
Correct.
Okay, yeah.
okay. And so the USB controller has some way to test the device, the cable.
It doesn't, but yes, so it does test the cable because, okay, so the way it is that your host controller actually has two hub inside. There is one USB 2 and one USB 3. So it knows which one is being taken because all the cables are always backward compatible.
Okay.
I see. So you figure out, hey, this looks suboptimal.
Mm-hmm. And we tell users, we're like, hey, it looks like there is a problem. You have a shiny USB 3 device that can do 10,000 megabytes a second, and you're running at 480. You should check the cable and the hubs.
And we just launched this, right? Like yesterday at Google I/O. So basically, I take my flagship phone, I pull the cable out of the box, and I plug it into Android Studio Koala. And as soon as I do, what happens?
You're going to have a notification that tells you, we've detected a problem. You should really check.
So we tell you when you connect the device, not when you run the debugger or...
Oh, yeah, no. It's always on. It's always on. It's not specific to the debugger.
Okay.
That's awesome.
Yeah, that's really good. So what should you do? How do you find the right cable? Then you just test a bunch of them, or do you have
I tried at home. I got to my box full of old cables, and I was like, and it's true. Cables that looked really professional, you know, with thick, nice coating. This is clearly a good cable. Nope, that was not it.
I'm lucky because I haven't seen the message yet, and
have you been used? No, it's not. We actually kept the flag off until.
Oh, okay. So I'll get the.
Yeah, Tor is right. Like some cables are braided, and they, depending on the amount of shielding, like you can have a really thick cable. You know, you came over to my desk, and I have those huge ones.
Yeah, they look really nice.
They are USB 2.
I mean, you discovered this that even at our local supply station inside of the Android team, right? We have this place you can go and get cables when you need them.
Yeah,
but they were also bad.
I went to the content. Yeah,
but so can you make assumptions like if you have a Thunderbolt cable, for instance?
Yes. So
that's what I always use because I know those are
exactly. So the thing with Thunderbolt is that they are certified,
and they have a special icon.
So if you go for a Thunderbolt cable, you know it's going to be in there. And also all Thunderbolt cable have all 12 wires. So this is something new. I talk about 8 wires, and with USB 3.1, they doubled. That's the multiplayer I was talking about earlier. So instead of having 2 lines, 1 up, 1 down, you have 2 up and 2 down, and you also have everything to carry USB 2.
So I jokingly said, 3 is 1 better than 2, but I'm assuming that when it comes to the duplex issue, you're reducing latency. But with the extra cables, you're probably getting a lot better throughput as well.
Absolutely.
So, if what is the net effect of going to a 3.1 cable, in terms of pushing a large APK, for example?
Yeah. So when you reach the world of 3.1, you kind of start to reach decreasing return. The huge bump is when you go from USB 2 to USB 3. But I was testing with Santa Tracker, which is an average app. It's 74 megs, something like that. You gain 2 seconds per install.
And that's out of
10 seconds.
Okay.
Yeah, so that's a big difference. And a lot of the install time is not just the USB transfer. There's other things happening.
There are other things, but it's mostly transfer because devices are so fast now that,
So how does that compare to, for example, ADB over Wi-Fi?
So ADB over Wi-Fi is using Wi-Fi, which is not as fast. ADB Wi-Fi, it's really very convenient.
Yeah, we've had a lot of users because we launched it a couple of years ago. By the way, we know there's some bugs.
Yes, I know. I'm aware of it too.
Yeah, and we have Fabien on the case now. So it's very convenient, but people should know that a physical cable is a lot faster.
So when you say faster, are you talking latency or bandwidth?
Everything.
Okay, everything. Because latency, I would expect it. Because if you have Wi-Fi 7 or something like this, it's starting to be. In terms of bandwidth?
In terms of bandwidth, it starts to be satisfactory, but the difference between Wi-Fi and USB is 2 orders of magnitude faster. Okay. And especially what you have to deal with Wi-Fi are interference.
Yeah, and of course, the quality of your own network and who knows, because bad cables, but also bad routers, bad switches, bad drivers. There's a lot of things that can go wrong.
And all the collisions with your toaster and every device around your house.
What, you don't have your network set to run every night to check for the best possible bands?
And they make them with 16 antenna now.
Yeah, it's ridiculous. I just upgraded my network to Wi-Fi 7. And when you have the right devices, it's really nice.
Well, what I learned today is I should plug the toaster in with USB 3 cable.
Right? And studio will tell you if it's appropriate.
That's right.
Please leave your toaster alone. But back to your point, Thunderbolt, one of the reasons it has to be so fast, it's meant to drive monitors. And at modern resolutions, at modern refresh rates with HDR and all that stuff, you need gigabytes per second.
You need even more. So, the Apple XDR, which is a beautiful, gorgeous display, it actually push Thunderbolt 3 to its maximum. That's why, depending on your configuration, the USB port behind are USB 2.
Right.
Because there's not enough bandwidth. But luckily, there's Thunderbolt 5 coming up.
So, because you touched on that, I wonder if you could also detect that, because I know on some laptops, the port on the USB-C port on the left is going to be faster than the USB-C port on the right.
Yeah,
Because internally there's a number of like, I assume PCIe lanes or something like this. And so they have to decide like where they send them.
Yes.
And you have to, and sometimes you have to know which side is better.
Is that something we can do?
To detect...
to suggest, hey, try
Switch
your
to the
other
other side.
port. And this might be harder, but I'm wondering if we know some well-known laptop models, we can go like, that model.
Well, I assume for this you would have to.
I can put it in the bubble, try the other port, but to detect in advance if the other port is better.
You would have to send.
You know what? I like to say everything is possible with computers. It's just a matter of time and money.
Or you may have to send some payload to test the speed.
Yes, but I mean those are so unreliable. Like I dislike to do these things because they work on you when you try, and then even if it doesn't work 0.5% of the time, given the magnitude of Android,
absolutely,
it's never gonna work.
All right. So check your cable, go buy better cables. And when you buy a cable, I guess you have to look at the details, like the specs of the cable. And
my advice is just if you want to be done forever, just buy a Thunderbolt cable and that's it. Even a Thunderbolt 3 cable. Right. You can find one for $20.
Which is expensive for a cable, but
when I buy tools,
absolutely.
I never go cheap on them. I come from a household when I was a child where all the screwdrivers were garbage. We had no hammer. So maybe that's why I like to build tools so much, and I like good tools. It's just like I like to spend a little extra on it.
I know where Romain's going now. This is one of his pet rants. So go ahead.
Yeah, no, I mean, mouse and keyboard, right? Like, why would you? Of course, if you can afford it, but like, if you're gonna use this 10 hours a day, I mean, spend an extra $10.
I thought you were talking about software, right? How people are so unwilling to pay for anything, yet
software is garbage.
Well, it's one of those things where like if you're using it every day, it's
important.
Yeah.
Well, also one of the things, and I don't know how it is in USB-C cables or Thunderbolt, but one thing that I find fascinating is how much more complex some of those cables are. Some of them are not just wires anymore, right? Like sometimes a good example is those adapters for your headphones to like plug into a USB-C jack. There's a computer inside. There's a freaking sound card with a CPU and an operating system, and that's why it costs $20 because they put a computer in it.
And it boots in what, half a second?
Not even,
It's amazing.
Yeah. So that's why some of those cables are expensive because they need to be. All right, so we have better protocol for the debugger. We can detect the USB cables. You mentioned the install time of the APKs. Didn't you do things as well to speed that up in the past?
Yes.
I remember with Zip and...
Yes. So one big optimization we created a long time ago, we called it Delta Push. And we're pushing the whole APK every time. But what if almost nothing changed? So if very little change, there are two things you need to do very fast. You need to update the zip, the APK, very fast. And then you need to push only that to the device.
Well, you also need to know what has changed, right? Which sometimes can take time.
So we built an agent. It's like a daemon that we push, and it's always up, and it keeps the connection open with Studio. And every time you click deploy, what we do is that we go there, and we're like, hey, do you already have it installed? And I'm like, yes. So we open the zip, and you can a zip is made in a way that there is a directory at the end. So we grab all that, we ship it back to the workstation, where we parse it. And there is a CRC, which is a hash, and a location. And if that pair has changed, that we know that this part is dirty. So then we need to reconstruct it, and we need to send only that. And we call that Delta Push.
So like in a modern APK, I might have like 7 classes.jars in there, for example. This would then push one of the classes.jar, or does it get even more fine-grained?
No, because the class is contained...
the DEX.
Yeah, it's in the DEX.
That's right. DEX.
So, but even if you push the whole class.dex, it's still just 1 or 2 megs. In most cases, instead of the whole like 100 gigs or maybe...
Yeah, because you're not re-pushing all the resources.
Exactly. So that was one part of the equation. The other thing is that we needed to edit a zip archive very fast. And that's why I wrote Zip Flinger. And the name is actually an homage to the software I worked before.
It's funny because I was visiting our teams in London last week, and they asked me the questions like, why is it called Surface Flinger? And so I tried to explain that, it's kind of, I guess, a joke from the author of Surface Flinger, Pixel Flinger, Audio Flinger. I think it came from BOS, or he was using the same names there.
He told me it was an homage to something called Pixel Flinger.
Well, you wrote Pixel Flinger for Android.
Pixel Flinger was an homage to something Flinger on BOS, yeah.
And so now everything is something Flinger.
I'm paying homage, and maybe hopefully somebody will write a Flinger as an homage.
And someday there will be some kind of like cult around like the name Flinger in computer science.
Yes, we're starting a trend.
So Zip Flinger.
Zip Flinger is a tool that allows you to edit a zip in place.
That sounds like a useful tool that could be used outside of.
And they do. Yeah.
It's used for all kinds of things in Studio.
Yes, and it's been so it's used by the build system now.
No, but I mean, even for Android developers, like, could they just, is it a command line
Studio,
tool?
Romain.
No, but actually it made its way to Gradle and what's this? Maven.
Nice.
So people are using it. I've had bugs report from people in like other companies be like,
and now you're in charge of Maven. Congratulations.
Awesome.
I'm sure that's what you wanted.
So it was very interesting to work with Zip because once again, you're like, okay, you want to edit a zip in place, do it. But a lot of people are going to parse your zip. You don't want to break them. So what do you do? So if you want to edit a file in place, you're going to create holes in it.
Yeah.
And the problem is that there are two ways to parse a zip, top down or bottom up. And if you do bottom up, you read the directory, you don't see the gaps. If you do bottom up, like for example, the GVM, the default implementation, you're like, oh, there is a break, there is a hole in there. That must be the end of the archive. So you miss half the stuff. So we came up with ways to fill the hole with what we call virtual entries, which have nothing, and we fill the space. And then
just to fool the parsers.
Just to fool the parser.
When we did resource shrinking for Android, it was the same thing. We discovered that, hey, no one's referencing this drawable, for example. So let's just delete it. And that crashed on certain phones because a different operating system was like actually traversing the resource index. And so then we ended up inserting dummy files instead.
In the index.
Yeah. So it couldn't be empty, but we could put something much smaller there. So they would get like an empty XML file or a 1 pixel PNG, things like that.
You know, it reminds me of when you try to hack a file, a program, and you need to like replace a certain number of bytes with new feature, and so that no one will complain about the.
Exactly. I should have talked to you about it, Tor, because you would have told me, don't leave holes in the zip, it's bad. But yeah, so ZipFlinker was working so fast. We were able to edit a zip in 17 milliseconds.
Nice. And so did you do any other special tricks like multi-threading, vectorized code, or is it just straightforward C?
No, because everything is so serialized in the way you're going to output the file anyway that So we did a lot of multi-threading, but I did not want to build it in the library because I did not know what was going to use it. If you want to use it in Gradle, in Blaze. Because ZipFlinger also made its way to Play Store. So every app being built right now is built with ZipFlinger. So it's like millions and millions of apps.
That's when they do the assembly from App Bundle into delivery.
Exactly. So what we've done is that we externalize the compression, because when you build a zip file, 99% of the time is spent deflating, like compressing a file. So that we took it out, and we're like, okay, the build system can build those files, compress them, and then give them to us.
Right.
And that is synchronized. So we purposely did not build multi-threading, but we let the door open for people who wanted to multi-thread.
Yeah, but it's interesting because it's always, I remember when I was working on Filament, we have this tool that we use to compile shaders offline. And the big question is, do I make the compiler multi-threaded because there was work that we could multi-thread, or do I rely on the build system calling the compiler to invoke multiple instances and use all the cores?
Typically, build systems are going to have their own pool of threads and so on. And you're just going to be fighting it if you do your own thread pool.
Yeah, but the problem is that, so in our case, like the load itself can be multi-threaded. And so, yeah, it's always delicate to know where you should put that work. But yeah, no, ZipFlinger looks really interesting. I can think of ways to use it.
I was very proud of it. And I built it using my experience on Filament, actually, because when I built it, I was like, I want no dependency, zero. Like maybe one for annotation, for non-null. And actually, it ended up serving me well because, serving Google well. But it's a win-win situation because it ended up being used in the build system. It ended up being used in Google 3. So it's like...
it's highly portable.
It's highly portable. And also, it really makes you not complacent. Because sometimes you need to do something and you're like, oh, I'm just going to use Guava or like this huge thing. But like you try to keep things tidy, and you're much more in control in the end.
And I'm assuming you had to write it in Java because back in the day, if you want to put it in Google 3, it has to be Java. That rule has since changed.
Yes.
But that must have been.
But also it goes back to what you were saying at the very beginning, right? Where sometimes to fix, especially performance issues, you may have to go through the whole stack. But at some point, if you don't have access, or it would take forever to convince, the authors of your dependency to do what you need, and they might say no, then you're stuck.
Yeah.
So when performance is what you need at all costs, and you can afford to not have dependencies, because sometimes,
don't implement your own network stack kind of thing.
Or more like don't implement your own encryption library.
Yeah, no, that's definitely a mistake.
How hard could it be?
It's not even about
it's secure.
Right. I'm not worrying about it being hard. I'm worried about all the mistakes I would make.
Yeah.
All right. Anything else interesting that you did, to optimize that whole stack for developers? Because I'm sure there are other.
The sad thing is that sometimes you do so much stuff that you forgot, and just right off the bat, I spend my time optimizing. I like to describe myself as a millisecond hunter. And
milliseconds?
Yeah. Well, sometimes you get lucky.
Nanoseconds.
Sometimes you get lucky and you find 1,000 of them, but
you can choose your own title at Google, right? So you can get that. You can get your profile updated to that.
I am actually a software wizard.
Nice.
Hunter of time.
Yes. What can I think of? No, I mean, the other big optimization I work on is live edit.
Right.
We wrote a whole VM interpreter, and we recompile class on the fly, and then you never have to push anything. It's instantaneous. And it's really funny because the first time I tried it, I was like, oh my God, this is magical. And then I'm like, oh, I wrote some of it. This is cool.
It's really, really nice.
So when you say an interpreter, like a full DEX interpreter or full bytecode, Java
full bytecode? Full bytecode. So the way it works is that every time you touch a class, we keep the PSI, like the AST. We send that to the compiler, to K2. I'm not sure we've switched to K2 yet.
We're working on K2.
Yeah. So you recompile it and you get bytecode, not DEX. That's what we push to the device. And
so you have an interpreter on the device.
Yes.
That is not art.
It's running on art. It's a Java class running on art, interpreting bytecode.
So you wrote a Java interpreter in Java.
Yes. Correct.
Okay.
Yes. And it supports everything, like every opcode, and that's how it works behind the scene.
But that means it's gonna run slower.
This only happens for the code you have changed, right? So it's
sure.
most of your app.
But no, look, I mentioned that cheekily, but that also means, so if you're using live edit, please don't do your benchmarking at the same time.
Yes, yes, that's probably not a good idea.
Yeah, just because you're not running what you think you're running.
And also, it's gonna the interpreter is gonna be optimized. It's gonna get jitted. And so,
I mean, we've actually added a bunch to the profiler recently to basically push people away from this, because a lot of people didn't realize that if you try to profile a debug app, you're kind of shooting yourself in the foot. And so now you actually go like, hey, what are you doing? You should switch to profilable, which is a special mode of your app.
Well, which was similarly to what you did for USB cables when you use the Jetpack benchmark library. If you're trying to benchmark on an emulator, we're going to tell you, no, don't do that. Yeah. That's not going to work. Or, there's a number of checks that it does to make sure that you're going to get results that you can trust. Yeah. So I like it when the tools help you figure out what you should be doing.
That's what they should be doing, right?
Yeah.
Yeah.
Yeah, especially, and more importantly,
people want to get paid to do that.
Of course, you can do that, but it would be nice if your tool would just order a cable for you. It's like, you have a bad cable, don't worry, you're getting a new one tomorrow.
Here I'm sitting thinking, there's a monetization opportunity. We'll put ads in Fabien's pop-up now.
We get a cut on every cable.
We'll use our own affiliate code.
We should sell good USB, Fab certified or studio certified.
Android branded cables.
Yes.
I'm sure the product manager for studio sitting here shaking their head. Engineers are...
I like the idea.
Yeah.
Cables you can trust.
Yeah.
All right. Anything else that is worth mentioning that you think was, fun to work on, or...
I mean, personally, I'm passionate about the field, so everything sounds fun. Like lately, I've been working on ADB, trying to remove backends to make iteration speed faster.
So what's a backend in ADB?
Oh, okay. So ADB, if you take it as a black box, there is one side which talks to the workstation. I'm talking about ADB server. There is an ADB daemon on the device. We're not talking about that. So one side is talking a smart socket, and that's what ADB client is doing. Or in the case of Studio, it used to be DDM-lib, and now it's ADB-lib. On the other side, it needs to talk to the device. So for that, it talks USB to the USB stack. And we have native backends. So there's a Windows, Linux, and Mac. And what the effort that has been started recently is to switch to libUSB, to have one backend. And
so it was our own implementation of a USB driver, or was it like okay?
Yeah, I mean, yes, we use for example WinUSB on Windows, we use IOKit on Mac, and we just talk directly to the USB stack. And the problem with that is that if you want to add a feature, you need to write it 3 times, test it 3 times, and you need to find a Windows machine, among other things. So it's very, very slow. But if you switch to libUSB, it's much, much faster, because for some of the aspects which don't go too deep, like for example, the USB cable speed detection, you write it once and you have it. So what we are in the process of doing on ADB is to move to just those backends.
Okay, so one unified backend.
One unified backend. Another type of backend we have, and it's to support ADB Wi-Fi, are the MDNS, because the way it works on ADB Wi-Fi is that they advertise, they communicate together with the MDNS.
This is for the pairing part.
The pairing part and the discoverability also. Yeah. And that was originally... Okay, I have even more detail, but I'm not going to go into that because I
have vague recollections of stories about MDNS a long time ago, and it wasn't pretty.
Yeah, so what happened is that on the Mac ship with MDNS daemon. So on the Mac, we use the Bonjour backend. On Linux and Windows, you don't have a daemon installed by default. So we had to use a different backend, which is called OpenScreen. And I don't know the details, but it was decided that we would have 2, depending on which platform we were on. And what we're doing on ADB is that we're going to move to have only one. And again, it's easier to fix bugs, and we can iterate much faster.
Nice. And
we've gotten a lot of feedback. People are sort of bummed that there's still bugs in this area. So, I'm glad we're looking at it. In general, we've gotten a lot of feedback. Hey, just, fix fundamentals. We knew debugging in particular was bad. And that's why a couple of years ago, we're like, okay, we're going to invest in this. And this is sort of the fruits,
USB has always been an interesting... I remember, like, again, the early days of Android, around Android 1.0, I could kernel panic my MacBook by just plugging in a USB cable on my and my phone. And even nowadays, like when I'm home, when my laptop wakes up from sleep, about twice a week, it just does a hard reboot because it's certainly connecting all the USB devices that are connected through my display, and I guess it's too much for.
And you have a Mac, right?
It's a Mac, yeah.
So imagine what it is on other.
Oh, could be better, like
It's not.
I mean,
it's not,
really, you get hard reboots all the time.
I've tried to love Linux for a long time, for almost 2 decades now, and then it's just a nightmare to have a Linux laptop. Like power management doesn't work sometimes, and
you have to get a laptop where the manufacturer provided the driver,
exactly.
right? Like if you're assembling it yourself and you're picking a driver that isn't quite for the right hardware, but close enough so it works, but that's when you're in pain. Yeah,
and don't even get me started on fractional scaling and all those. Wayland things.
Look, I was vaccinated a long time ago when I was using laptops in the 90s, and I was just trying to get X11 to show up not in black and white. So, I have color. I'm happy.
We've come a long way, but there's still a long way to go.
Yeah, but it's interesting because it's something that I don't think developers or let alone users understands, that on Android, just like any big project or operating system, I assume, we tend to make those like pretty big changes in the core. Like, you're swapping out the implementation of what makes ADB works, and everything goes through ADB. And you will never know unless we tell you, like in a podcast, for instance.
Yes.
And it's always like a bit scary and also very satisfying to do.
Yes. And we do a lot. It always breaks my heart when I read the bug report and they're like, you people don't care. And I'm like, this is not true. I care so much.
It's a hard problem.
Yeah.
It's easy
because it's not break backward to remain backward compatible is something that we've done very, very well on Android. I'm very proud of how much effort we put into it, and also on Studio, of course.
I mean, the thing that working on Android taught me is I have so much respect for the Windows team at Microsoft and the level of backward compatibility they achieve. You can find online on YouTube, there's videos of someone who like starts with it's in a VM, right? But it starts with like MS-DOS, whatever version. He runs an app and then he upgrades all the way to like Windows 10 and keeps running the same app and it works.
Yes.
And that is just mind-boggling to me. And on Android, like, in a way, our life is easier because it's not like you can't really open your phone and like swap out the RAM and the hard drive. And so, it's
same on Android. I wrote a game a long time ago. It was a shut them up. I published it maybe in 2009, 2010. I never updated it until they deprecated 32 bits. And all I had to do was recompile to 64. And I used the same libraries and everything, it was still working.
Ooh, we did something right.
Yes.
Once. All right. Well,
I think the other challenge for tools is that Android, a lot of it, basically the Android OS is Linux-like. But the second, for the tools, of course, we ship on all these other operating systems. And so, for example, you're dealing with it in the ADB stack. It has to run on Windows and Mac and Linux. And so it's all different.
Well, I imagine Windows particularly must be challenging, right? Because at least on Mac and Linux, there's a lot of similarities given their roots.
Except when there isn't.
Sure.
And things like layout rendering too. We're kind of running the view stack, but we're running it on Windows.
Yeah, but a good example is like on Windows, we have you have to install drivers, right? That you don't need on Mac and Linux. So yeah.
Did you say the drivers for the device?
Yeah, don't you need drivers for like...
No, that's something else I discovered when I was working on ADB. You no longer need that.
Oh, okay. We got rid of that.
So all the driver does is emulate WinUSB.
Mm-hmm.
It comes pre-installed with starting with Windows 8.
Okay.
So you have it. And something amazing that we also added to Android is that when you connect the device, if it's a Windows machine, it tells the Windows machine what driver do I want.
Right.
So the USB controller say like, connect WinUSB to my interface, please. And it does that, and ADB finds it.
So it's transparent?
Yes, but a lot of people did not know about that. And actually, people who are working on Android on a VR device, and like, should we still tell people to install drivers? I'm like, no, it's no longer needed.
Nice. Well, yeah, like you said, you care, and there's a lot going on, and I'm sure we'll still have a few problems that we need to solve, but...
Yeah,
we have a list, but we can't give away, all of our surprises, right?
No, we need to keep
That'll be next year's episode. We'll talk about all the other cool things you're going to do next.
Sounds good.
Yes, please have me again. It was fun.
With pleasure.
To bore you with all my details.
It's not boring at all, actually.
No, and I think, like I said earlier, I think our audience is super technical too. So, whenever we do technical deep dive, they appreciate that.
So next time we'll give you a whiteboard and you can start,
I don't know. After that hair, I'm pretty sure I'm going to have a bug open. Like, so you said 4 wires, but it's actually not exactly true because...
if anyone has any questions about anything you heard today.
Right. And speaking of questions, there was a question about Compose and Figma and Relay. Do you remember the question?
Yes. So if anyone has questions, post them on our YouTube channel. And so after the Compose episode we had recently, someone asked, can you make it easier to interact between designers and engineering? I think it was basically boiled down to that. Like, what are you doing to sort of let Compose have designs? Figma was mentioned in the question.
Well, I mean, if the question is, can you make it easier than using Figma and Relay? Figma and Relay are the easy way.
Well, I mean, another thing we're working on now that we just demoed yesterday at I/O is
going to talk about AI.
I'm going to talk about AI. Is basically Gemini's multimodal capabilities, right? And so one of the demos we did was, basically uploading screenshots and saying, "Hey, Gemini, what's the Compose code look like for this? Please use Material 3," and you get some code. Again, it's not fully automatic where you just point your code base and it just fixes it all. But I think it's another approach.
Can I ask Gemini if my cable is a USB 3 cable?
Who knows what it's going to tell you?
Yeah, no, I mean,
shoot a photo of my cable.
we actually do know that a lot of people ask about their code base. And of course, currently, the model doesn't have access to your code base. And this, I think, is sort of the future direction, right, of AI in general, is making it smarter about... It's called retrieval augmentation, right? But like that's clearly...
we already did an episode on AI recently.
Oh, I can keep talking about it. So anyway, I think for the Compose question, obviously there's a Relay project.
Right.
And
So Relay, for those who don't know, it's a plugin for Figma, and it will generate compose code from your Figma design directly. So you don't have to take a screenshot from your designer and try to recreate it by hand. So it's going to accelerate development.
yeah, and more importantly, and an advantage over the Gemini answer is that it lets you iterate, right? So you can come back, do some more work in Figma, and it'll do some sort of a smart sync. You're not like, okay, throw away that last attempt, start over, right? Whereas with the Gemini current approach, there's a little bit more of that.
Yeah. So if you have questions about everything that Fabien talked about today, let us know, and we'll try to
suggestions.
answer.
If you have ideas,
Please.
we're open to those too. Like, what are the pain points where we need someone who's like an expert at figuring out how things work and improving them? Could do good.
Make everything faster, please.
Yes, and more reliable. I mean, that's the other thing, right? Like the whole timeout thing.
Yeah.
That was another reason why we started funding debugger work, was we knew that there was a certain failure rate of breakpoints being missed, but it wasn't reproducible. What's going on, right? And it's been fixed. So,
all right. Well, thank you so much.
thank you.
Thank you.